Hey guys, my name is Ethan, this is Carberra, and welcome to the series where I teach you how to analyze and visualize data in Python. Today we are starting with our first of the sort of like the mathematical segment, I guess. There's going to be a few videos in this showing you how to do certain operations. For example, in this one I'm going to be showing you how to do linear regression. So we're basically going to be finding a line of best fit in our data to see if it's positively or negatively correlated. Of course, if you find the video helpful at any point, then consider liking to let me know and subscribing so you don't miss out on future videos in this series. Yeah, with that out of the way, let's get into it. So you may have immediately noticed that my IDE looks a lot different. You don't need to change anything. I just decided to refresh my theme and I'd changed the font as well because the new Visual Studio Code update made Monokai look like crap, let's say, to call it lightly. So I decided to change it all up and refresh my theme for the first time in years. So if it looks different, well, it does look different, but all I'm saying is that you don't have to change anything on your end. There was also a storm outside. I don't know if it's still going, but if you do hear any thunder, then that's what that is. But yeah, with that, I will talk about our imports. So we have our matplotlib import because we are going to be graphing to show what I'm talking about. We have pandas as well, and we have seaborn as normal. We also have this from sklearn.linearModel import linear regression. And this linear regression is what we're going to be doing today. So linear regression is essentially plotting the line of best fit in data. It shows you what the correlation of data is, whether it's positive or negative, by sort of averaging out the data. I don't know the background maths behind it, but it averages out all the data and draws a line pretty much through the center of it. And you'll see what I mean with here. But if you've done, say, line of best fit in maths or whatever, then this is pretty much exactly that. It's just given a different name, and we're doing it with computers now. So dataset we're going to be using is the second half of 2020 for those following along with the same datasets. Of course, if you want to use your own and see what correlation that data has, then feel free to do that. But just make sure that the data you're comparing is just two columns, and I'll explain why in a bit. So I'm actually going to insert two cells, and we're going to start on this one down here. I'm going to put a function in here. Actually, we'll just shut it off real quick, or at least I'll set it up like that. And I should probably actually run this. There we go. To load in our data. So the data we actually want is from our DF, and as I said before, we need to pick two columns. So I'm going to be picking views and red views. So what I'm trying to work out here is whether an increase in views also means an increase in people that are watching through YouTube Premium. It's not called YouTube Red anymore, but in the API it still is for backwards compatibility's sake. And we also need to convert it into a Numpy array, and we can do that just by doing dot values. And we don't need to worry about the rest of it. That just creates a two-dimensional NumPy array with all the data we need. So I can actually probably print out the data and show you what that's doing. Yeah, there we go. So this is the views column, this 488, and this is the red views column, 23, 7, 10, etc. So with NumPy arrays, we can access individual columns at a time, which is going to be very useful for what we're about to do. So to get the 0th column, we do something like this, and if we run that, you'll see we get all of the rows, but only from one column. And then we can do the same with 1, and we can get all our red views as well. And this is how we're going to be differentiated between our X and our Y axes when we go to actually do some linear regression. One more thing I want to show off before we get into it is the reshaping. So we are going to need to reshape our X data. So we can do that using reshape -1, 1. Make sure this is in a tuple, that's very important. And it creates a two-dimensional array where every individual row has its own array. And this is basically just inverting the axes. It makes it actually possible for the regression to predict what it wants to predict. So we don't actually want any of this here because we're going to be doing that in the function, but we do want our pred. So this linear regression returns a series of points that we can then draw a line across. And these are called our predictions. It's a term that came from machine learning algorithms and such, where you plot an AI's predictions of something on top of the true data, and you can get the errors from that. It's just kind of a term that's pulled over. We're not really using AI, but the term pred makes, I don't know, maybe it's just me because I kind of got into this stuff through AI. Maybe I just took the word pred from that and it's not actually used. But, you know, that's something for future me to worry about, I think. So now that we have this in here, we can actually go and create our function. So we want our x and y, and then we want to get our data as we did before. So .0.reshape. And then -1, 1. Again, make sure this is in a tuple. That is very important. And then our y data can just be x, colon, and then a 1. Where is my cursor gone? There we go. And after that, we need to create the linear regression model that we're going to use to actually calculate all this stuff. So we could just do that like this. You don't need to pass any arguments into it. I think you can pass arguments into it. Again, I don't know where my cursor's gone. Visual Studio, go into, there we go. So you can pass all this stuff into it. We don't need to do any of that for this, but you can experiment with that if you want. Then we need to actually fit the data to our model. So this just kind of tells the model that the data is here. This is data we want to work with, and this is data you should use when doing our predictions. So we do rega.predict x. What we're doing is we're predicting the y values for all of the values of x. So every value of x already has a value attributed to it in the data, of course. But when we're drawing a line, we want to predict, you know, where we should put the dot on the y-axis for each element in x. So I suppose I was right then, because it uses predict there, and that returns a numpy array similar to you know, this, but instead of our true data, we have our predicted data. And with our predicted data, we can now draw it onto the graph. So we could do fig equals plt dot figure, and then we can draw our actual data on here. So data equals df, x equals views, y equals red views. And then we can draw the line of best fit onto it. So we do x equals df views, so we just use the same. And then our y equals our pred, and we're going to set a line width equals 3, just so we can see it a bit better. And we do fig.show. You can see that we just have a line through the center of our data. So this shows us that the data is positively correlated. So yes, indeed, when I get more views in a day, I also get more red views in a day, or premium views. Which, to be fair, is to be expected, but this graph shows it to us using this nice little line that we can see. So if I change this to scatter plot, you can probably see what is going on a little bit better. And you can see that it actually does plot the data here. So whereas a line graph goes dot to dot across one axis to draw a line, so if we go back to, where were we? Line scatter, episode 10. Can run all this, and then, oh, never mind, we can't run all this. I'll put an image on in the edit to show you that, but it goes, you know, dot to dot, joining the dots. But because all the dots are in a completely straight line, it just draws a completely straight line, and we end up with this. And we have the answer to the question of how this data is correlated. So that's it for what I wanted to talk about in this episode. In the next episode, we'll actually be talking about polynomial regression, which is where, you know, the line can curve and do all this crazy stuff. It's a little more accurate. I've lost the keyboard again. For some reason there's some bug in VS Code where the keyboard just decides it doesn't want to work anymore. I don't quite know why that is, but I'll try and figure that out at some point. But yeah, if you've got any questions, don't be scared to leave them in the comments below, or you can join the Discord server using the link in the description. But with that, I'd like to thank my amazing patrons for being as incredible as they are, and I'll see you next time where, as I said, we're doing polynomial regression. So it's like this, but just with curves. Ooh, it's all very fun and exciting. So I'll see you for that.